Okay, let's go ahead and start off with section 18I, laws of probability. What we're going to do is we're going to use Venn diagrams to prove a couple of very important rules and formulas for probability, and that will be based on Venn diagrams. So let's take a look at our Venn diagram. Here we have a normal deck of cards plus the two jokers. So notice that we have the kings, there are 4 kings. The diamonds, we have 1 king of diamond, of course, which means that the other 12 cards are in here. Then we have the 2 jokers and all the other 36 cards. Okay, so let's go ahead and use this to go ahead and show some of the important probability rules that we want to show today. Now, of course, if we're going to go ahead and determine probability based upon a Venn diagram, we're basically talking about counting. And so when we talk about the probability of, say, for example, a king, then what we're going to do then is we're going to say, well, we're going to take a look at the number of kings that we have and divide it by the number of cards that we have. So in this case, if we go ahead and determine what the probability of choosing a king would be, well, I would go here and I would say, well, there are 4 kings. So the number of kings would be equal to 4. And the total number of cards is 52 plus the 2 jokers, that's going to be 54. So that would be the probability of choosing a king out of a single deck of cards. The 2 jokers remain in the deck. Okay, so that's how we can calculate very simple probability. Now there's going to be a very important law of probability that we need to discuss, and that's talking about the probability of, say, for example, K union D, or the probability of a king or a diamond. Now, before we go and do that, we're going to use this idea here that if we can count, then we should be able to divide everything by the number in the set of cards, in the deck of cards, and then we can actually determine what the probability would be. So let's go ahead and take a look at just the number of cards that we have. So the number of cards that are kings or diamonds. Well, if we go ahead and think about the kings or the diamonds, this is 3 plus 1, which is 4 plus 12. So that's 4 plus 12, that would be 16 altogether. Now, what that means then is that we can actually look at this and say, okay, that's actually the total number of kings that we have, which are 4, of course, plus the total number of diamonds that we have, which of course is going to be 13. Now, if you go ahead and you take a look at that, we already know that we're over 1. Now, why is that? And the reason why is because actually we're counting the king of diamonds twice. We're counting the king of diamonds as a king, and we're counting the king of diamonds also as a diamond. So what that means then is that we need to essentially go ahead and subtract the king of diamonds because we're counting it twice, and we only need to count it once. So there you go, you have 16 is going to be equal to 17 minus 1, which is 16, and there you go. So what we need to do then is we need to go ahead and come up with a law of probability that would correspond with this. And of course we know that this is going to be true. So what that means then is that if I actually just go ahead and divide everything by the number of elements in U, which in this case we know is to be 54, because we included the 4 jokers. Well, that means then that what we've actually described here is the probability of K union D. That's of course going to be the probability of K plus the probability of D minus the probability of K intersect D. Okay, and there you go. That's how we can now go ahead and determine what the probability of getting a king or a diamond would be based upon what we have there. So what we can do then is we can just go ahead and use this calculation as such and say, in this particular example, that the probability of choosing a king or a diamond is the same thing as the probability of a king. The probability of a king we know is going to be 4 over 54, which we've already discussed right there. The probability of a diamond, of course, is 13 over 54, minus the probability of the intersection of the king and the diamond, which we know, of course, is going to be 1 over 54. And this would, of course, be equal to 16 over 54, and that's the probability of getting a king or a diamond. Okay, so we now know how to go ahead and use this right here with our Venn diagrams, because all we need to do is count to determine the probability of a particular result. And we can now also go ahead and find the probability of A union B. Now the other condition that we need to go ahead and also take a look at is this, of course, assumes that you have intersection. But what if you don't have any intersection? So say, for example, instead of this, what if we wanted to talk about